Hey everyone, my name is Sanjeev and I will be your instructor. In this course we will learn about AWS's Elastic Container Service and how we can use it to deploy a container-based application. We'll start off by going over the basics of ECS. What is it? How does it work? And we'll get familiarized with the different components that make up the ECS solution. So we'll learn about tasks, task definitions, and services. In addition to that, we'll also learn about the different launch types that we have. We'll talk about the different pros and cons of each one, as well as when you would use one over the other. And once we have a good grasp of the core concepts that make up ECS, we'll then move on to deploying a couple of different applications onto ECS. We'll cover all of the main configurations necessary for this, and I'll go over what each one of these configurations do and when you would want to use one option over the other. And I'll also show you how you can deploy a new version of your application onto ECS as well. And finally, we'll also take a look at how we can integrate a AWS load balancer to direct traffic to your ECS cluster. So we've got a lot to learn. Let's go ahead and jump right in. We're going to kick things off by going over what is ECS and why we would want to use it. So what is ECS? ECS is AWS's managed container orchestrator. And so being an orchestrator, it's going to put it in the same family as a Docker Swarm or a Kubernetes, but this is just one that's provided by AWS and is managed by AWS exclusively. So let's quickly discuss what an orchestrator is so that we have a basic understanding of what is the ultimate goal and purpose of a solution like ECS. So an orchestrator, the main purpose of it is to manage the lifecycle of a container. So it's going to be the one that's responsible for finding available resources or a server to create a container and run it on. It's going to be responsible for creating the container, it's going to be responsible for destroying it, and if the container ever crashes, it's going to be the one that restarts it or creates a new instance. So it really is the brains behind everything. Orchestrators are also responsible for deploying and load balancing the application across multiple servers. So if you're ever just working with Docker or Docker Compose, you're kind of limited to one server, but in reality, when you're deploying an application, you would never want to just deploy your application onto one server. That's going to create a single point of failure. You want to be able to distribute it across multiple servers so that if one goes down, the other servers can pick up the slack. And orchestrators just make this a lot easier. The other thing is we want to be able to auto scale to handle variance in traffic. So if we have a very small application and then for some reason our app grows and becomes very popular, we might see a spike in demand for our application, and we need to be able to handle that spike in traffic by automatically auto-scaling our application, creating more instances of our container so that we can process all of the incoming requests. And then if our spike starts to subside, we want to then lower the number of instances so that we're not paying for extra compute power. And lastly, when we make changes to our application, updating our code, we need a way to efficiently roll out our code without disrupting the end user's experience, and orchestrators make this very easy. So I want to quickly just walk through the workflow of deploying an application onto a plain Docker environment with no orchestrator. So that could be just using the traditional Docker run command or using Docker Compose. And so you're going to define your Docker Compose file. That's going to have all of the configurations for all of your containers. And let's say that we have a couple of different servers. Well, one of the limitations with using Docker Compose or Docker Run is we can really only deploy it onto this one application. So if we ever wanted to scale it out to all three of our servers, we can't actually do that with Docker Compose. Now, we could technically copy the file over to the other servers, but you're not truly managing your application across three different servers because none of the three servers are aware that the same application's running on the other servers. So it's not truly orchestrating your application across the three servers. So that's one of the main limitations. And in addition to that, let's say that we want to create more than one instance of our application to handle more traffic. We want to be able to scale up easily, and we want to be able to scale down easily. And we want our orchestrator to be intelligent enough to do it on its own without us having to manually intervene. And that's something that Docker Compose is not able to do. And in addition to that, like I mentioned in the previous slide, if you ever need to update your application and roll it out to different instances so that we can do this without disrupting end user traffic. We don't really get that ability with Docker Compose. We need a more intelligent service. We need an orchestrator to do that. Now, when it comes to traditional orchestrators like Kubernetes or Hashicorp Nomad or Apache Mesos, these all require a lot of effort to get up and running, and they're not exactly the simplest or most intuitive to work with. Especially with Kubernetes, we all know how much of a beast that is. And so ECS was created to create a simple alternative to these orchestrators so that we can basically just use a simple GUI, put in a couple of details that we want when it comes to how we want our application to operate, and AWS is going to handle the rest. EC2 has two different launch types. It has an EC2 based launch type, which if you don't know what EC2 is, this is just AWS's compute service. So it's just a virtual machine that they provide you. And it also has a Fargate service. And I'm going to go over both of those in detail, but I want to discuss one more thing real quick, which is the concept of an ECS cluster. So what exactly is an ECS cluster? Well, to define what an ECS cluster is, I want to talk about what is ECS in itself. And it's important for you to understand that ECS is nothing more than the brains behind how your containers are deployed. ECS only works with containers. It does not have any other ability. So when you deploy a container, it still has to run on a physical machine or a virtual machine. But ECS doesn't act as a server. ECS doesn't have any servers. ECS doesn't have any compute power. ECS can only just create and delete containers, but it still needs the underlying infrastructure to be able to run those containers on. And so that's what a cluster is. A cluster is just a bunch of resources, the underlying resources that your containers are going to run on. So they're going to be based off of a bunch of EC2 virtual machines, and ECS will just be responsible for deploying your containers onto that underlying infrastructure. So your cluster, once again, is nothing more than the underlying resources that your ECS instance can deploy your application on. It's the physical infrastructure. So with an EC2 launch type, the most important thing to understand is that we have to manage the underlying EC2 instances. So we have the ECS control plane, which, as I mentioned, is nothing more than the brains behind the operation. And then we have our cluster. And like I said in the previous slide, the cluster is going to be the physical resources that our containers are going to run on. And with a EC2 launch type, we have to manage the underlying infrastructure, as in we have to manage the EC2 instances. So we have to create the individual servers or the individual EC2 instances ourselves, and we have to manage these EC2 instances. So we have to install Docker on it because it's going to be running containers. We have to install the ECS agent. So when you're working with ECS, and specifically with an EC2 launch type, your EC2 servers have to have a special agent so that the ECS control plane can talk to it and give it instructions. And with any other server, you're going to have to do the usual maintenance things like installing a firewall so that you can only access certain ports so that you're not opening yourself up to any unnecessary vulnerabilities. And then with any other server, you're going to have to apply routine patches, routine upgrades so that your servers are all up to date. And that's the most important thing to understand with an EC2 launch type. You are managing the servers all by yourself. You have to do all of the work. You have to maintain them. You have to upgrade them. You have to patch them. And the only thing that ECS does is manage the containers. So you manage the EC2 instances. ECS just deploys the containers onto those EC2 instances. And with this type of launch type, what you get is full control over your infrastructure. You own the underlying EC2 instances. You manage them. You can configure them exactly how you want. With ECS Fargate, AWS is now going to manage the underlying infrastructure. So we're going to have the same ECS control plane. We're going to have our cluster, just like we did before, but now we're also going to have this thing called Fargate. And what's important to understand is that when you're working with Fargate, it follows a serverless architecture. And what that means is when you take a look at your cluster, you're going to see that there's no EC2 instances. There's nothing there, right? That's just like how serverless operates, where there's no physical servers. Well, from the perspective of you deploying an application, you don't see any of the physical servers. You don't have to interact with them. You don't have to create them. But when we go and create an application and send it to ECS, what ECS is going to do is it's going to see that we have no servers to run our application on. So it's going to talk to Fargate, And Fargate will create the servers on demand. So it's going to actually create the underlying resources, whether that's EC2 instances or something else. Fargate is going to handle all of that. And once those instances get created, now ECS can then deploy our containers onto that newly created infrastructure. And the great part about this is that you do not need to provision or maintain the EC2 servers. Fargate does all of that for you under the hood. And the nice part about this is that you only pay for what you use. So if you delete your application or scale it down, it's going to remove the underlying resources, so you're not paying for an EC2 server that's just constantly running all the time. So now let's talk about a couple of the different components or pieces that you're going to have to configure from an ECS perspective. And we're going to start off with the ECS task definition file. So as a user, you're going to have an application and you're going to Dockerize it by creating a Docker file. And then once you have that Docker file and you create a Docker image, you can then upload this to Docker Hub or any other repository. And after you get that uploaded to Docker Hub, now it's time for you to define a task definition file within ECS. So this is something specific to ECS, and the task definition file is going to act as a blueprint that describes how your container should launch. So it's going to contain all of the container-specific configurations like the CPU, the memory, what image it should use, what specific ports should be open, what volumes should be attached to it. And so it's basically going to contain all of the configuration that you see within a Docker Compose file. So you're just defining the specs for your specific container. And a task definition file can contain all of the configuration for more than one container. So you can put your entire application in one task definition file, or you can split it out depending on how you want to configure it. So we discussed what a task definition file is. It's just the blueprint for our containers and how they should be deployed. Now let's discuss what a task is. And a task is nothing more than an instance of a task definition. So a task definition, remember, is just the instructions. When we actually want to create an instance of our application, we create a task. So if I wanted 2 instances, we would have 2 separate tasks. So a task is just a running container with the settings defined in the task definition file. It's kind of like a Docker image, right? A Docker image is the blueprint to how a container should be created, but a physical container represents an instance of the Docker image. So the next thing I want to discuss is a concept called a ECS service. So what is a service? A service just ensures that a certain number of tasks are running at all times. So let's say we have an application and it's just a simple Python application, and we want 2 instances or 2 containers of our application running at all times. We would provide this instruction to the service. We're going to say, hey, I want 2 separate tasks or 2 separate instances of my application. And the service is going to say, okay, right now I see that there are 0 instances of your application. I'm going to go ahead and process your request and make sure that there are 2 are running. So it's going to create 2 instances and deploy it on some available servers within our cluster. In addition to that, it's also going to restart any containers that have exited or crashed so that we always have 2 instances running. So if this one goes down, the service will notice that and it's going to create a new one or restart the pre-existing one. On top of that, it's also going to monitor the EC2 instances. And if any of the EC2 instances fail, the service will actually restart the task, and it will restart the task on a working EC2 instance. The last thing I want to discuss is load balancers. So let's say we have our application deployed, our services managing it, and we've got a couple of different instances running on several different services. We can assign a load balancer so that we can route external traffic to your service, right? The purpose of a load balancer is just to make sure traffic coming can get routed to all of our resources, and it's going to be responsible for making sure that traffic's evenly load balanced across each of the different instances. So we can take a load balancer, assign it to the service. When it receives traffic, it will then be intelligent enough to understand all of the different instances, where they're running on which servers, and it can route the traffic to them. And if we scale up resources, so we add a new instance, the load balancer will be able to intelligently pick that up and forward traffic to it evenly as well. Before we get started working with ECS in the AWS console, I want you guys to go to Docker Hub and take a look at the two following images. So I've created two demo projects that we're going to use for the ECS tutorial. These are public repos, so you guys can pull them down as well and follow along with the tutorial. And you can reach them at Kodekloud/ECS-Project1 and ECS-Project2. So for project 1, which is going to be the first one that we start out with, this is a plain old Node.js application with a Express server. So if you send a GET request to the root path, you're going to get a plain old HTML file with some text that I've written on. And this server is actually going to run on port 3000. And if you take a look at the Docker file, it's just a simple Docker file. And we're going to be starting the application and running it on port 3000. That's the only thing you guys really need to know. We're going to be running on port 3000. So when we configure it in the ECS console, just make sure that that's the port that we expose. So at the console, what we want to do is search for ECS, and we're going to select the Elastic Container Service. And here you're going to be prompted with a wizard. If you've never used ECS before, they've got a get started or like a quick start wizard that's going to help you get things set up pretty quickly. So we're going to do that at first. And then after we do that, we're going to delete everything. And I'm going to show you how to deploy everything manually because I think it's important to understand. So we'll go ahead and hit get started. They've got a couple of example apps, but what we're going to do is select custom. And so here we're going to provide all of the configurations for our container. We're going to give it a name. I'm just going to call this ECS-Project1. The image, that's going to be the image that I just mentioned. So it's going to be Kodekloud/ECS-Project1. If you have this image hosted on a private repository, then you would select this and put in the credentials. But it's public, so we don't need to do that. If you want to put in any memory limits, you can do that. Here, this is where we have to specify the port mappings. As you recall, if we go back to the Express configuration, we can see that the app is going to be listening on port 3000. So we want to expose that port. So I'm going to put 3000, and it's going to be leave it as TCP. Now, you might be wondering, in Docker, normally when we do like a Docker run, we would do Docker run, and then you'd do -p, and you'd expose two ports, right? The outside port, and then the port that the container is going to be listening on. With ECS, you don't do the two ports. It's just going to be one. So the outside port is always going to be the same as the inside port. So it's always going to be, either 3000, 3000, 4000, 4000. What you cannot do is say, I want to expose port 80 and map it to port 3000. You can't do that with ECS. They have to match. So I'm going to select this, set this to be 3000. If you want to take a look at the advanced container configuration, you can see that you've got sections for health check. Here you can add environment variables. And then there's volumes down here. So it's basically like all of the settings that you would add on a Docker compose file or on a Docker run command, but you're just doing it through a GUI. So we're just going to go down and you could specify resource limits, labels, and things like that, but that's all the configurations we need. So I'm going to hit update. So we've got our ECS project 1. I'm going to scroll down. I'm going to hit next. Here we can define our service. So it's going to create a service called ECS-Project1-service. We can add in a load balancer. For now, we're going to leave that selected as none. And then here, this is going to be the cluster name. So this wizard is actually going to create the cluster for us. And remember, the cluster is just all of the underlying resources that our container is actually going to run on. We'll leave it as default for now. And you'll also see that it's going to create a brand new VPC as well as some subnets. So our cluster is not going to run on the default VPC. It's going to create a separate one for us so that everything's kind of isolated. I'll hit next. Here you can just review your configuration, and you'll see that it's going to create a couple of different things. We've got the container definition, we've got the task definition, we've got the service and the cluster. And so I'll hit create. And we'll just give this a couple minutes, and I will sync back up with you guys once that's done. And so once that's complete, we can just hit View Service. Now, before we verify that the application was successfully deployed, I want to go over all of the different things that the ECS Task Wizard created for us, because it did do a lot of things behind the scenes. I want to make sure you guys understand what actually happened. So the first thing that we want to do is go to task definitions. And so, during the lectures, we covered the task definitions, and the task definition file is just going to be the file that contains all of the configurations for all of our containers. So this is going to contain things like the port mappings, the volumes, environment variables. So anything that you would configure within a Docker Compose file, or when you're running Docker run, the different flags, that's what's going to be defined here. So in my browser, you'll see that there's a couple of different task definitions. That's just some of the other projects that I had going. If you guys are using ECS for the first time, you should see only one task definition. That's going to be that first run task definition. So select that, and you'll see that there's, in mine, you're going to see a couple of different revisions. So that's because I ran this a couple of times. But what happens is you should see probably just a 1 here, and that implies that this is the first revision. And so anytime you want to make changes to the configurations for your containers, you would create a brand new revision. So the higher the number, the more recent the revision is. So if you want to see what the latest configuration is, just select the one with the highest number. And if we take a look at this, this is going to contain all of the configs for our containers. So there's some default configurations here. We can see that this is going to be running on Fargate. But if we go down here, we can see how much memory was assigned to it, how much CPU. And then down here, this is going to be the one container that we deployed. We can see that the host to container mapping, port 3000 to port 3000. There's no volumes or anything like that. No environment variables. And so that's really all of the configurations. So the task definition just has the configs for all of your containers. There's only one in this case, but you can put more than one in a task definition file, or you can put them in separate ones depending on how you want to deploy your application. Now, if we select clusters, this is going to show us the cluster that wizard created, right? Because the cluster is going to be all of the underlying resources that our containers can actually run on. We are using Fargate. However, if you chose to deploy it on ECS cluster, then this would contain all of the EC2 instances. So if I select the default cluster that was created, we can see here a list of the different services. So that wizard also created one service for us called ECS-project1-service, and we can see it's in an active state, and we can see what task definition files associated with it. And we can see that the configuration points to one desired task, and we have one in a running state. So it looks like everything's good. If I select this, we can take a look at the specific service and the configuration for this service. We can see all of the network related information like the VPC, the subnets, and the security group. And if we go to tasks, this is where we can actually take a look at the tasks. So we've got one task in this case that's currently in a running state. And we can take a look at this task and get some more information. So we can see, once again, it's in a running state. But more importantly, we can see that we have a public IP. So this is the IP address that we use to access our application. So I'm going to copy this and open it in the browser. And we can see that it just keeps spinning and it looks like it's going to error out. And that's because, remember, our application runs on port 3000. So what we want to do is port 3000. And we can see the demo application, right? This is just a very simple application. I wanted to keep it simple for the first one. And so it's just going to send out an HTML file. So this does confirm that our application was successfully deployed. We got a chance to see the underlying cluster that was deployed, the task definition file, as well as the service. So now that we've verified that the application was successfully deployed, I want to delete everything. And I want to do everything from scratch without that quick start wizard. So I'm going to go back. And the first thing that we want to do is go to our cluster. Go into our default cluster. I'm going to select this service, and I'm going to delete it. Here, we'll just type in delete me for confirmation. It's going to take a few seconds. We should see that all of our tasks also get deleted. And if the task doesn't need to get deleted, go ahead and just manually Okay, so now our task was deleted as well. And if we go back to our cluster, I'm going to select the default. And what we're going to do is we're going to delete the cluster as well. All right, and now our cluster has been deleted. So now we are basically starting from scratch. So there's nothing in our ECS, there's no configuration. And now we're going to take a look at how we can deploy everything from scratch without that quick start wizard. Okay, so the first thing that we want to do is let's create our cluster. So I'm going to select create cluster. And you'll see that there's three different options. The first one, where it says networking only, this is going to be if you're using Fargate. And then you have two options for if you are using EC2 within the cluster. So we've got one where the EC2 instances are going to use Linux AMIs, and we've got one for the Windows AMI. Now, just to keep things simple so we don't waste our time creating EC2 instances, I'm going to do Fargate. We're going to give this a cluster name, so I'll just call this cluster1. Call it whatever you'd like. We're going to create a VPC. You can change the default CIDR block and the subnets, but I'm going to just leave that as is. So it's going to create a VPC with this CIDR block with these two subnets as well. And we'll go ahead and select create. All right, so now our cluster has been created. We can just select view cluster, and it's going to take us to that specific cluster. We've got cluster 1 now created. So now that we've got the cluster set up so that we can actually deploy, the first thing that we're going to do is create our task definitions. So I'm going to go to task definition. I'm going to create a new task definition. Since this is going to be running on Fargate, we're going to select Fargate. We'll give this a name. I'm going to call this ECS-project1. And I'll just call this task def. And here we have to select a role. So if you went through that initial quick start wizard, it's going to have already created a role for us. So just select that one. If you didn't do that, just go ahead and just run through the quick start again, and it's going to create that role for you. ECS has to have certain permissions to create some of the underlying resources and things like that. Everything with Amazon and AWS requires explicit permissions. And so this will already have all the permissions set. Here we'll select the operating system. We're going to run it on Linux. We're going to leave the same execution IAM role to the same one. Here we could specify the task size. So this is going to depend on what are the requirements for CPU and memory for your application. Since this is just a simple demo, just go ahead and select the smallest ones. Then we'll add in a container. And here this is going to be ECS. I'll just call this node app. Image, that's going to be that image that we used before. And then once again, we're going to do the port mapping of 3000. If you want to change any of these extra configs, you can do that, but we don't need any of that. So I'm just going to select add. And then I'll hit create. So now we've got our task definition defined. I'll select view task definition. And remember, this is just going to be the blueprint for our application, for our task. But we haven't actually created an instance. We just create. So now we have to create the task itself, or the service, which will be responsible for creating the task. So we'll go to service, which is going to be in our cluster. So I'll select cluster 1. And then here we're under the services tab. We'll create a service. Launch type, this is going to be Fargate. Operating system, we'll do Linux. Then for the task definition, you have to look for the specific file that we created. So ECS project 1. And then you could select a specific revision. We'll select the latest. This is just the cluster. We're going to leave that as default. Then give it a name. So I'll just call this project 1 service. Then number of tasks. So this would be how many instances of that task definition file do you want created. So remember, we just have one container in that task definition file. It would create, if we selected one task, it would just create one instance of that. If we selected 5, it would create 5 instances of it. So this is how you kind of scale up your application. So if we want to do 2, I'll select 2. This should create 2 instances of it. We'll leave everything else as default. We'll do next step. Here we're going to select our VPC, the one that we created specifically for ECS. We'll select the 2 subnets. And then we'll select the security groups. So this is just going to be what traffic do we allow going to our specific ECS service. So I'll select edit. We can create a new security group or just modify an existing one. So I'm going to create this new one called project. We can see right now it allows traffic to port 80. However, remember, our application isn't running on port 80, so this would actually break our application. Instead, what we want to do is change this to be port 3000. So I'll do custom TCP port 3000. And you want to do from anywhere. So, that means, regardless of where you are located and whatever your IP address is, anybody should be able to access it as long as they go to port 3000. I'll hit save. We'll leave everything as default. In this case, it's asking if we want a load balancer. I'm going to say no thanks. We will cover that in a bit. We'll hit next step. Here, this is where you could specify auto scaling so that it can auto scale based on the demand of your application. We're going to just leave that disabled for now, but this is where you would go to enable it. And then we can review all of our configurations, and I'm going to select create service. And so our service was now created. If I select view service, it's going to take us to our service and the tasks. Right now you can see there's no tasks, but if I just hit refresh, we could see that it's now provisioning 2 tasks. Why is it provisioning 2 tasks? We selected, we wanted 2 instances of this, so it's going to create 2 different tasks. And they're all going to use the same exact task definition file, so it's basically identical copies of the same application. And if I select one of these tasks, you can see the current status. Right now it's in a pending state, and that's because it's in the process of actually deploying our container, so it's going to take a few minutes. But eventually that should move into a running state if there's no issues. So I'll go back. We can see one's in a running state. If I hit refresh, now we can see both are in a running state. If I go to the task, we'll just grab one of the tasks here, and I'll grab the public IP. And I'll put that in there. We can see our application works. And if I go back and select the next one, interestingly enough, this has a different IP. So for some reason, each one of these different tasks gets a different IP address. And this is kind of a pain because if you think about, like, if we deploy a front-end application, right, we shouldn't have to know all of the underlying IPs. It should just be able to go to one specific IP and it should automatically load balance across both of the tasks. But this just verifies that it did work. So this is a little bit of an issue because ultimately our front-end application shouldn't have to know both of those IPs. And if we scale up, it would have to keep learning all the different IPs. And then if we start scaling down, it would have to lose some of the IPs. And so this is where a load balancer would come into play. We would define a load balancer that would automatically load balance traffic to all of these different tasks. And then the load balancer would expose one single IP that our front end could consume. And like I said, we're going to cover that in a bit, but there's a few other things I want to cover before we get to that. Now, let's say we make some changes to our application. In this case, I'm just going to make a very simple change. I'm just going to add some exclamation points to that H1 tag. And once we make changes, we're going to have to then create a new image and push it up to Docker Hub. So I'm going to do a Docker build. Give it a tag of Kodekloud /ECS-project1. Okay, so we built a new image. Now I'm going to do a a push for that image. So we've updated the image in Docker Hub. But at this point, if we refresh our application, nothing's going to change, right? Because we have to tell ECS to pull the new image. So how do we do that? Well, we'll go back to our ECS console. And there's a couple of ways of doing this. The simplest way is if you go to clusters, go back to your cluster, select the service, select update. and then you just select Force New Deployment. So that will cause it to pull the latest image and then redeploy. However, if you were making other changes, not just changing an image, let's say you change the task definition file. So in this case, if I go to Project 1 Task Definition, and you select Create New Revision, you could just create a brand new revision. And so now we have revision 2. And so since nothing's really changed from a configuration perspective, since we did change the revision, it's still going to pull a brand new image. And so if I go back to my service, we can select the latest revision and then just skip to review and then select update service. And then if we go back to our service, we should see that in tasks, we have the previous 2 tasks running, and now it's starting up 2 brand new tasks. And what's going to happen is these are going to boot up, and then once they're in a functioning state, all the health checks pass, it will then go and shut down the old 2. Okay, so now we see all 4 of them in a running state. So now that these 2 are in a running state, it's now going to move these to a shutdown state. Okay, so one's now been removed, and in a second or two, the next one should get removed as well. All right, so it looks like we're now back down to 2 tasks, as we've set the desired count to 2, and we see the running counts too. So let's go back here. And I'm going to go and just hit refresh. All right, so I'm going to go and select one of the tasks. Now, what's important to understand is the IP address changes. So when we create a new deployment, the IP address changes as well. And so I'm going to do that and then do port 3000. And we can see that we have the exclamation points. However, I do want to focus on the fact that the IP address did in fact change. This is a problem as well. That would mean that anybody that's using our application would have to remember that our IP address changed. And this also can be addressed with a load balancer. A load balancer fixes both of these problems. So a load balancer will automatically point to the new IP address, but the load balancer's IP will always remain the same. So anybody that's either consuming it from a front end perspective or from a client, their IP address will always point to the load balancer, and then the load balancer will get updated anytime we make changes to our application. Okay, so now what we're going to do is delete our entire application. We no longer need this, and I'm going to show you guys how we can deploy a slightly more complex application that involves a database and a volume, and we'll take a look at how to set up a load balancer as well. So I'm going to go to my service, and we're just going to delete this. I'll go to tasks, and let's just verify that it was successfully deleted. Okay, so now everything's been deleted. We still have our cluster. There's no need to delete that. We're going to deploy our second application on there as well. Now for our multi-container application, this one's a little bit more complex. It's got 2 different containers. I've created a dummy example Docker Compose file just to kind of give you guys an understanding of how the architecture of our application works. It's pretty simple. We have 2 containers. We've got an API container, so this is just going to be a simple Node.js or Express API. And it's going to be using this specific ECS-project2 image that we've already uploaded to Kodekloud. And you'll see there's a couple of environment variables. I'll cover that in a second. Once again, we're going to be exposing port 3000. It's going to be running on that same port. But the major difference is there's going to be a Mongo container. And so this is just going to be using the default Mongo image. And to get Mongo working, we have to provide 2 environment variables, which is going to be the root password, the root user, and then the root password. Right now, I just kind of set that to be Mongo and password just to keep it simple. And because this is a database and we want the data to persist, we want to define a volume as well. And then whatever username and password we specify here, we have to also provide it here as well. And then we also have to give the IP of the Mongo container and what port it's running on. And if you want to take a look at the app, I'm not sure what your programming background is. However, it's just a simple API. So if you take a look at the code here, this is just going to be a simple CRUD application where you can create notes and delete notes. And so here, the first endpoint is if you send a GET request to /notes, it's going to retrieve all the notes in our database. If you send a GET request to /notes and then provide an ID, it's going to give you information for one specific note. If you send a POST request to /notes, this is going to be so that you can create a brand new note. And then we also have a patch to /notes. And then the ID, this will be used if you want to update a pre-existing note. And then we also have a delete option. So if you want to delete a specific note, you just do a delete request to /notes and then the ID of the note. So it's a pretty simple application. It's going to be using the Mongoose library to connect to the Mongo database. Once again, running on port 3000. And the important thing to understand is we have to pass in the environment variables for connecting to the Mongo database. So just keep that in mind. So before we get started, I'm going to create a security group for our ECS application. And so if I just search for security group, this should be under EC2. Security groups under EC2. So I'm going to open this in a new tab so I'm not constantly moving back and forth. And I'm going to just create a brand new security group. I'm going to call this ECS SG for security group. And I'm just going to say ECS security group. And remember, the security group just defines what traffic is allowed to go to what device. Right now, I'm going to just add in a simple rule that says all traffic. We're going to allow all traffic, which you don't normally want to do. You want to specify exactly what traffic is allowed and isn't allowed. And here I'm going to say I'm going to allow traffic from any IP. So pretty simple. It's not, this security group is doing absolutely nothing, but we'll update this later on. I just wanted to create this ahead of time. And more importantly, make sure you provide the correct VPC. So this is the VPC of the ECS cluster, so you want to make sure it's the same VPC. And then I'll select Create Security Group. And once that's complete, I'm going to go back to our ECS page, and I'm going to go under Task Definitions. And here I'm going to create a new task definition for a new application. This is once again going to be Fargate. And I'm going to call this ECS-project1. Task role, it's going to be the ECS task execution role. Memory, I'm going to just select the smallest ones. And now we're going to add our containers. So the first one, we're going to start with the database, the Mongo container. So I'm just going to call this Mongo. And the image, we're going to use the default Mongo image from Docker Hub. The port mappings, this is going to be the default port for Mongo, which is going to be 27017. We don't really care about the health check or the environment. However, we do want to add environment variables. And so the two environment variables are going to be listed in this Docker Compose. So we want Mongo initdb root username. And we can give it any username we want. I'm just going to say the username is going to be Mongo. And then we have to provide the password as well. And I'm just going to use password, not secure at all, but that's okay. And we'll select value here. So we've got the environment variable set. The next thing that we want to do is, actually for now, we can just close this. I think that's enough configuration on the Mongo side. Let's add our second container, which is the Express application. So I'm going to call this maybe Web API. The image, this is going to come from our Docker Hub. And so this is going to be ECS-project2. And this image is also listening on port 3000. And this is going to have 4 environment variables. So we need the username for the Mongo database, the password, the IP, and the port. So I'm going to copy all of these. And then the other one's going to be password. So the username, it's going to be the same one we set on the container for the database. It's going to be Mongo. Password is going to be password. Now the IP is going to be a little bit interesting because if you've ever worked with Docker Compose, you'll know that Docker provides us DNS resolution. So for the IP, I could just say to reach the Mongo container, I can just provide the name of the service into there. So I could just say Mongo. However, with ECS, we don't have access to that. There's no DNS built in. But instead, what we can do is we can make use of localhost. So you can reach your other containers that are defined in a task definition file through localhost. So I could just say localhost, and then it's going to use whatever specific port that the Mongo container is running on. And so we know that the Mongo container is running on port 27017, and so we could just provide that here. So when this container wants to talk to the database, it'll send a request or send the traffic to localhost port 27017. So that's how communication works between containers within one specific task. And just like with a Docker Compose file, you can add in dependencies. So if you wanted to say, I need the Mongo container in a starting state beforehand, you can add that in here as well, but I'm not going to worry about that too much. But really, any configuration that you can add on a Docker Compose file, you can add in here as well. And so we'll add that. The last thing that we need to do is we have to define the volume. So we have a volume for our Mongo database. And to do that, we have to go to the volume section down here. So I'm going to select Add Volumes. We're going to give this a name. I'm just going to call this Mongo-DB. And then the volume type, we're going to make use of AWS's Elastic File System. And so we're going to have to create a Elastic File System because right now we don't have any. So you could just select this link. Amazon's already provided that for us. And we're going to go there and create our Elastic File System. We'll select Create File System. We'll just call this Mongo-DB. Make sure you change this VPC to be your cluster VPC. Standard is fine. Make sure you select Customize. We have to make one change. We'll go to Next. And this is where we're going to make the change. So make sure your subnets are selected. If they're not, just go ahead and just select the drop-down and pick your 2 subnets. We're going to change the security groups. Right now it's using the default security group. And if we use this, you'll see that our containers will not be able to communicate with the Elastic File System. And so what I'm going to do is I'm going to actually create a new security group for this guy. So I'm going to go back to the EC2 Management Console, go under Security Groups, and we're going to create a brand new security group. And I'm going to call this EFS Security Group. Just give it some description, EFS Security Group. Make sure we update the VPC. The protocol is going to be NFS. And the destination, this is where things, this is where we can be a little bit more specific. Right now it's accepting traffic from anyone, but what we can do is instead of just accept traffic from anyone, because that's a little bit of a vulnerability because then anyone can access it, what I can do is I can say, use the security group that we created for ECS. Remember that previous security group that's associated with ECS? We could say only traffic coming from that device. So this allows us to kind of narrow down the scope of who's allowed to talk to our Elastic File System. It's only that ECS instance. And I've actually made a mistake. This was actually the outbound rule. I don't actually want to do this to the outbound rule. So I'm going to just change that back to all traffic, and then just allow that to everyone. We want to add a inbound rule. That was my mistake. So we'll change this to NFS, custom, and then we'll select that ECS security group that we created. So we create that security group. Let's go back to the EFS window. And we can see it's not there, and that's because we have to refresh it. So I'll hit previous. And just go ahead and select default for a second. And just hit previous. And then go back to next. And it should reload it. So we'll exit out those. And then now we can select EFS security group. And select that for both. And make sure you delete the default one. We don't want that. We just want one security group. We'll hit next, next, and create. Okay, so now we got our Elastic file system. And so now if I hit refresh here, we should see our file system. Everything else can be left as default, and I'll select add. So at this point, what exactly did we do? We did the equivalent of defining a volume down here. But we now have to associate that volume and provide a mount point in the container itself. So to do that, we have to go back up to our container, select the Mongo, and there should be a storage and logging section. So here, select mount points. We're going to select MongoDB. And we want to mount it in what path inside the container. That's going to be /data/db. So if you don't know where to mount the data for database, you would just check the documentation. The Mongo documentation told us to mount it in /data/db. And I'll hit update. And now we can go ahead and create our task definition file. And I realized this should be ECS Project 2, not Project 1. And we can see that it was successfully created. So we can select View Task Definition, and we can take a look at the final task definition file. And on mine, you'll see that we've got 4 revisions. You won't have 4 revisions. You'll just have 1, but I created this a couple of times beforehand, so that's why we see it's already on the 4th revision. So now that our task definition is created, let's create our service. So we'll go back to our cluster. I'll go to cluster 1, and we will create a new service. This is going to be of type Fargate. We'll do Linux. We'll select our new task definition. And we'll give this a name. I'll just call this Notes App Service. Number of tasks, we're just going to do 1. Everything else we'll leave as default. At the top, make sure the proper VPC is selected, and we'll select our 2 subnets. And for security group, we're going to select a pre-existing one, and that's going to be the one that we created called ECS-SG. And right now, it's allowing all traffic, so it's not doing anything. But once we create our load balancer, we'll be able to say only traffic coming from our load balancer should be allowed. And we can apply that type of policy within the security group, just like we did with the EFS security group. And now we're actually going to add in a load balancer as well. And that way, if we have multiple tasks, the load balancer can load balance the traffic to all of the tasks. And when we deploy a new task or update our application, we don't have to update the IP address our front end points to. Our front end will always point to our load balancer, and that IP will never change. So we'll select application load balancer. And right now it's going to look for load balancers that we have configured. We do not have any configured, so we actually have to configure it ourselves. So I'll select open link in new tab. And there's a couple of different types of load balancers. We want the application load balancer. We'll give this a name. I'm going to call this Notes LB. We want internet facing, and we want IP address type to be IPv4. change this to be your proper VPC. And then we're also going to create a brand new security group for our load balancer. And I'll call this LB-SG. And for inbound rules, normally what we would do is we would do, custom TCP, and then we would allow port 3000 because this security group determines what traffic is this load balancer allowed to receive, essentially. And our application runs on port 3000, so we would just listen on port 3000. However, I don't want to have the users or our front end send traffic to port 3000. I would rather just have them send it on the default HTTP port of 80 or the default HTTPS port of 443. And the great part about load balancers is what we can do is we can set up a policy that says any traffic that we receive on port 80, we can then redirect it to port 3000 in our container. So that way our load balancer is listening on one port and our containers are listening on a different one. So for the security group, I'm just going to use the default HTTP, and we'll say receive traffic from anywhere. We will create the security group. And I realized I made this in the wrong VPC. So I'm going to go back. I'm going to delete this security group and redo that again. So this will be LB security group. And this is where I forgot to change the VPC. I'll add in the same rule, so we want just HTTP. So now that we have the security group, we'll go back to the load balancer configuration. I'm going to hit refresh. I'm going to delete the default one. We don't want that, and we want the load balancer one. Now this is where we set up those rules that allow us to kind of receive traffic on one port and send it to another port. And the way that you define these rules is that you tell your load balancer, what port do I want to listen to traffic on? And so here it's saying right now the default example is it's going to listen on port 80, which is perfect. That's what we want. And then we tell it to forward it to something, which is our ECS cluster. And to tell it to forward it to something, whether it's the ECS cluster or EC2 instances, we have to define a target group. So a target group is just a list of resources that we can load balance traffic to. So once again, this is going to be something where we have to create another entity within AWS where we're going to select the create target group. So I will open this in a new tab. And we have to specify what type of target it is. If you're doing ECS, you want IP addresses. If you're just kind of configuring a target group for like standard EC2 instances, it would be instances, but we're using ECS, so it's always going to be IP address. Target group name, I'm just going to call this notes-target group 1. We can leave all of this as default, IP address type IPv4. Make sure the correct VPC is selected. Now, this is important, actually. So our load balancer is going to be performing health checks. And it's going to determine if a node's healthy or not based off of these health checks. So the way the health check works is you specify, whatever protocol, which in this case is just regular HTTP or HTTPS. It'll send a GET request to a specific URL that your application is listening on. And if it gets a 200 or a successful response, it's going to assume that the node is healthy and up. However, if it doesn't get a response or it gets like a 404 or something like that, then it's going to assume that the node is down and not working, and it's going to not direct traffic to it. So it's important that you set this up properly, and by default, it sends it to the root path. And if we take a look at our application, you can see that we don't actually have any routes that are listening on the root path. The root path is just going to be just /, but it's our application's listening on /notes, /notes, and then ID, notes ID, notes ID. So we have nothing listening on the root path. So the default health check would fail because we don't have. Now I could create a new endpoint and call it maybe like health check or something, and then I can change this to be health check. So just some endpoint that our application's listening on. But instead of doing that, I'm just going to tell it to send a request to the /notes endpoint, and it's going to get a response back with the list of notes. And that should be successful if our application's working. So I'm going to say /notes. And then if we go to advanced health check settings, we want to override the port. And we want to send it on port 3000 because that's what the containers are listening. And I'll select next. Okay, make sure the correct network is specified. And we can just select create target group. And so now our target group has been created. And if we go back to the load balancer, hit refresh, we can see that it is now successfully in this list, and I'm going to select that. And everything else looks good to go, so we will just select create load balancer. And we have now successfully created our load balancer, and we can go back to our original ECS window and finally select load balancer. So we did all of that to get our load balancer set up, and so it automatically filled it with notes LB. Then the next thing that we have to do is specify what container do we want to load balance traffic to, because we have two containers. We have the API and we have the Mongo container. We don't want the traffic going to the Mongo container. We want it to go to our web API, and it automatically knows that it's going to be listening on 3000, port 3000, so it's going to set up the load balancer to automatically forward to that port. So we can then go to, then we can select add to load balancer. And you know the configuration where we configured on the load balancer that should be listening on port 80? Here we're just doing the same thing, so ECS will overwrite any of the other configs we already did. So we're kind of just redoing the same thing. So production listener port, this is going to be what port is our load balancer going to listen on. So I'm going to select port 80. You can also do a custom port, but we want to listen on port 80. And so traffic's going to come in on port 80. And we want to forward it to that target group. So the target group is going to be notes TG1. And we can see that the health check path has already been updated, so that's good. And everything else should be good to go. I'll do next step. Here you could specify your auto scaling. I'm just going to leave it as disabled. And we can review our configurations, and we can select create service. And our service was successfully created. We'll go to view service. We can see that we have one task that's in a provisioning state. So we'll give it a minute or so and watch it move into a running state. And I'll show you guys how to make use of the load balancer to forward traffic to the containers. And so now it's moved into a pending state. Okay, so now we see that the task is moved into a running state. If I select this task, we can see both containers are in a running state. And if we wanted to, we could technically go directly to the container by grabbing this IP. And since this is an API, I'm going to use Postman to send a post request. So I'll just put a request to that specific IP. And remember, the API is running on port 3000. And we want to send a GET request to the /notes, and this should return all of the notes. And we can see we get an empty array, and that's because we don't actually have any notes. So that's one way of doing it. But remember, we set up the load balancer so we don't have to worry about this. And to use the load balancer to send traffic to it, let's go back to our load balancer. Actually, we could probably take a look at the ECS console here. And if we go to the cluster, go to services, click on this service, I can select on this target group. And if I go to this target group, we can see the load balancer associated with this. And so this is our load balancer. And if you take a look at the configuration for the load balancer, down here, you'll take a look at the DNS name. This is where we can now send requests to. So when we send a request to this DNS name, it will forward it to the container. So I could just replace this. And remember, I no longer need port 3000 because our load balancer expects it on port 80, which is the default HTTP port. So I could just remove that and just say /notes. And if I hit send, we can see I get an empty result. So now let's try sending a post request. And in the body, I'm going to add some JSON. I'm going to include a title and a body here. If I hit send, we can see that I get a response back. And now if I do a GET request, I should see my one individual note. So we have successfully deployed our application using that load balancer. And there's one last change I want to make, and that is that in our security group for our ECS, this security group right here, I want to change something. If you take a look at the rule, it's going to allow traffic from any IP address for any ports, and that's not very secure. Instead, I want to say I only want to accept traffic coming in from our load balancer on port 3000. So we're going to delete this rule. I'm going to add a new rule, custom TCP port 3000. And here I'm going to say I want to only allow traffic coming in from that load balancer security group. So our load balancer. And after we make that change, we can now try sending a request, and we can now see it still works. So we just made it a little bit more secure so that only traffic from the load balancer arrives on ECS. Alright guys, so that is everything I wanted to cover in this video. Hopefully this gives you a good starting point as to how to deploy an application onto AWS using their Elastic Container Service. Let me know in the comments if this is your preferred method of deploying a containerized application, or if you prefer an alternative like EKS. And I think that's going to wrap everything up, and I will see you guys in the next one.